In question 10, we will be graphing simple polar equations, also find area and the distance. The first question is about surveillance. A mounted surveillance camera oscillates and views part of a circular region determined by theta is greater than negative 60 degrees but less than 150 degrees. That's the range. And the radius is 0 to 40, where r is in meters. Sketch the graph of the region that the security camera can view on a polar grid. It's all about polar equations. Polar grid is required. The polar grid is circular. I'll just show you over here. This is the grid. The answer is visible, but let me explain what exactly is happening. Here, theta is the angle. So you know the angle is always from right to left. We get the angle theta, right? So that's in degrees or in radians. So now, whenever we solve polar equations, try to keep in mind we usually use radian mode or radians, okay? So this is very important. Now, here the angle is given in degrees. That's fine. We are just graphing. It's easy to graph in degrees, but when we are solving any area or anything like that, we cannot use degrees. We have to convert to radian mode, okay? But graphing just like this, very easy in the degree mode because it's much relatable. Now negative 60 degree means we have to go the clockwise direction. This is anti-clockwise, we are going left side. Clockwise would be negative degrees, so it's minus 60 from here, from the polar axis, that's over here, x coordinate, we just go back to 60 degrees. Is it 60? Yeah, it's 3. This is 360 degrees minus 60 would be 300 degrees. So we draw a line over there. And then positive 150 degree. Where is it? Over here, we draw another line. And then what's the radius? 0 to 40. From 0 till 40, this is 40 here. We draw the arc. That's the polar, that's the sector. So that's it. Now, this is the electronic part of your exam, so you will have 4 graphs. Just choose the correct one. Very easy to recognize which is the correct graph. Now, what about the area? Now, we have to find the area, right? Let me just do it over here. We need to remember the formula for area, that is given as half pi r squared, but pi is like theta, okay? The degree. This is a modified formula. This is for sectors when we are really dealing with polar grids. The area will be equal to half. This is constant. What is this theta? Theta is the angle. So how much is the total angle here? It's 150 plus 60, so that is going to be 210 degrees, isn't it? But do we write 210? 10? No, we are write in radians. So let's convert 210 to radians. So conversion to radian mean we want radian, that's pi above, divided by 180 degrees. Now imagine if you had 2 pi, how to convert to degrees? We know pi radian means 180 degrees. So all we need to see is if this is radians, you can't have radian, it should be degrees up above. So I write 180 degrees divided by pi. So what happens? Pi cancels. 2 times 180 is 360 degrees. So 2 pi is 360 degree, right? Same way over here we have 210. But now imagine, I'll just consider this 360 degrees. I want to convert to radian. Since degree I need to cancel it, I write degrees down here and pi up here. Why? Because pi is 180 degree. Now degrees cancel. This is 2 times, this is 1 time, so it's 2 pi. They are equal to each other. Same way I have 210 degrees multiplied by pi by 180. Now you can leave it like that or you can simplify it. Here zeros, you can just use your calculator, guys, in your exams. So this is 3 6 times, this is 7 times, so it's 7 by 6 pi. So this is the theta. What about our radius? How much is the radius? It starts from the polar pole over here, that's the 0, the origin, till 40, so it's full 40. So we just multiplied by 40 squared. So this is squared, not degrees. So you just put that in the calculator and there you go. That will be the answer for the area. So it's half. You can write 0.5 times 7 by 6. Or you can write this entire thing, 210 pi. That's up to you. Multiplied by pi, that is shift, and over here. Multiplied by 40, that's the radius squared. So the answer will be, you press this ST, it's 2932.15. They did not tell to round it off to anything, so we'll just take 2 decimal points, that's enough. So that'll be the answer. They have rounded off to the nearest tenth, but it's up to you. You just have to see which is the correct answer from the options, right? This is the correct one. So that's how we solve this. Now here we have different pair of polar coordinates for each point such. Okay, now this is given over here. Now this is the polar grid, right? It starts from 0 here, 90 here, 180, 270, and then again it goes to 360, isn't it? So we start like this. Now the radius over here is told to be phi. Imagine this is the radius phi. Here you can see the angle is not within 360. That means it's 960. It will keep on going one time, second time is 720. It keeps on going few times. But we don't want the whole circle. We just want it within the range of 0 to 180 degree. So what happens is, imagine for simplicity's sake, let's take 270 degrees. So it would go like this and over here, right? But now it cannot be 270. It should be within 0 to 10. So what you do is the radius is there, right? Imagine the radius was 5. So it would have been like this over here, this point, right? Take the negative radius. So if you take instead of 5, comma 270 degree, what is the other angle for this coterminal angle? It will be over here. That is minus 5, comma 90 degrees. So we just take the opposite side. So this is the basic understanding. You don't need to go through all this. I'll tell you a shortcut method since it's electronic part. Now here what we can do is we can just use our calculators and look at the question. They're asking for 180 degrees, right? All you need to do is write this 960 and keep subtracting 180. How many times? If you just subtract over here once, no. It should fall within 180. The number over here must be 180 degree or lesser than that. It should be within this range. It will happen if you keep on subtracting by 180. If they had asked 360, I'll show you. You just subtract it by 360. Sorry, yeah, it's 360. Once, no. You can do it again. So I'm just messing with the numbers. Okay, now it's correct. So this is within this range of 360. So this would be the answer. 5,270 degree. But since it's 180, we don't use 360 here. We start subtracting by 180. Again, subtracted by 180. Subtract by 180. I know at least, but still it's above. Now what we will do is one more time. Now you can see it's 60 degrees. So I got the angle over here. The answer will be 60 degrees. But what about the radius? So let us count it. It's 1 time 180 is taken, 2, 3, 4, 5. Since it's 5 times, this means it'll be in the more than 180 degree over here somewhere. So what you need to do is just subtract. We have to take the coterminal. Just write this phi as minus. So in the shortcut method, all you need to remember is keep subtracting by whatever they have given. How many times it's done? 1, 2, 3, 4, 5. If it's an odd number, just change the the radius to negative number. That's it. Now let's do this one over here. It's 5 pi by 2. You can convert everything to degrees if you find it easy. So 5 by 2 pi conversion will be just multiply by 180. The answer is 450 degrees, right? You can subtract. That's already, now the problem is you should not take it as an answer. You should take it as 450 degrees. Subtracted by 180. Once, no. Again, subtracted by twice, yes. Now it is within the range. So what this means is within 2 times we got, this is an even number, right? So the sign will remain the same. So the radius will remain the same. Minus 2.5, comma 90 degree would be the answer. But here, since it's in radian, we have to convert this 90 degree to radians. That will be pi by 2. Or if you're getting confused with the degrees to radian, let me just take this value here. 5 by 2 pi. Shift and over here. Subtracted with pi. That's 180 degree, right? See, it's 0 to pi. No, we need to have within pi. The 3 by 2 is 1.5. That's no good. We will subtract it by again. Now look over here. It's half. Half is within this, right? 0 to pi. Yes, it's half pi. That means this is the answer. How many times we have subtracted pi? 1, 2. So it's even number. We keep this radius same. So you can see the answer over here will be minus 560 and minus 2.5 and pi by 2. Same thing can be done over here. You just have to subtract it so many times. by pi here, and over here it's 180 degrees. Count the number. If it is even number, you leave the radius. See this, when you subtract over here, it'll be even number, so the 4 remains the same. Here also it's even number. You can see k was even, so it will be the same value. If it was odd, you change the sign. Now this one as well, please do it by yourselves. Now this one changes. Look here. What happened? Odd number we will get. You can try it and you'll get odd. And the same thing over here. It's odd number again. So we replace with minus. We just multiply a negative sign to this and we get positive 6. Another real world problem. Suppose a singer is performing at an amphitheater. We can model the situation with polar coordinates by assuming that the singer is standing at the pole and is facing the direction of the polar axis. This is important. Let me just draw a rough figure. This is the pole, right? The singer is over here and this is the polar axis, isn't it? 0. So he is facing like this, okay? The seats can be described as occupying area defined by negative 45 degrees. So somewhere over here to positive 40. So all this region, there are seats. And look over here, the radius is from 30 to 240. Imagine this was 240 degrees. It's not from 0, it's from 30. It's somewhere over here. Is that clear? So I drew this wrong. It should be, I'll just change the color here. See, this and this sector. This is the region with the seats. I hope that's clear. It's from 30 degrees to 240. So these are the sectors. All these regions have the seats covered. So we have to sketch the polar grid. This is the sketch. Okay, it's not accurate, but it's okay, you know. See here, it's from, don't start from the 0. What I did was I started from 0, but then I realized radius is from 30. So you need to start it from 30 here, and then it goes until 240, as you can see. So that is how we get it. And then these are this is the sector where the seats are there. There's another question. If each person needs 5 square meters of space, how many seats can fit the amphitheater? So let me get this back. Now here we need the area, but the problem is we are not starting from 0. The area formula I told you, half theta r square. But here the issue is the radius is not a single from 0, right? There are 2 radiuses. So imagine you start from 0. Then we get this entire sector, okay? And then what is this region? This is from 30, right? Let's take the radius first, 240. You will get the entire sector, and then we'll take it as 30 and subtract this part, so you're getting the remaining actual part. So the area would be here half theta of 240 degrees, the south side, multiplied with r 240 degrees. Basically, you can substitute the proper values itself. Let me just properly substitute. What is theta? It's 45 up, 45 down, so it's 90 degrees, but we can't use degrees. We have to use radians. 90 is pi by 2. You need to remember a few things, like 90 is pi by 2, 180 is pi, 270 is 3 pi by 2, 360 is 2 pi. These are some basic things you need to remember so that you can easily convert in your mind itself. 45 would be just divide this by 2, it will be pi by 4 and so on. So here we will use pi by 2 multiplied by, what is the radius? It's 240 squared. That's the outer radius. See from here. That's our outer minus, again the same thing, half pi by 2. Why? Because it's the same degrees, right? But here now the radius is only 30 squared, the inner radius. Outer minus the inner. So this is out minus in. Now you just put that in the calculator, you will get the answer. Let's do it. So it's half, that's 0. You can remove half and pi by 2 outside, but I'll just substitute everything directly because calculator does the job for you. Pi by 2 multiplied by 240 degrees. So it's 40. Again, my bad. Okay, minus, open the brackets now, because otherwise minus will be only considered for the first thing. But since it's all multiplied, it's okay. But still, always open the brackets. It's much better. And pi by 2 over here, divided by 2. That is multiplied by 30 square. See, now I had done a mistake over here. I had not put square. After multiplying by 240, It's square. See, I've written over here as degrees. Please don't do that mistake in your exam. It's power 2. Now then, the answer would be so much 44,532.07 square meters. Now the thing is, each person requires 5 square meters, right? This is correct now what we got. But it's not the final answer. We have to divide it by 5. See, whatever we got is absolutely correct. That's the area of the sector after we solve it up. But then divide it by 5. Why? Because each person requires 5 square meters of area. So the final answer would be, so many 8,906.42. That's basically 8,906 seats can be fitted in this particular amphitheater. So that's how we solve this problem. Here, it's again a similar thing. It's just that, see, they have given you everything, but we do not know what is the radius beginning at. We know the area, but we don't know the inner radius. So let me write the formula. Area would be equal to half into theta, that is the outer minus inner, right? So I'll write outer, O, r outer square, minus half times theta inner, and over here inner radius the whole square. So all you do is substitute what all you know. We know the area is 314.16 equals half. What is outer? This is theta doesn't change. Theta will be theta only, okay? For both it'll be same, so you can just ignore that. Only the radius changes. So I shouldn't have even written that, but anyways, if you see the theta that's given over here, 5 pi by 6, and over here it's pi by 6. So here, remember, this is the angle. It's not a negative positive. So what we need to do is 5 pi by 6 minus pi by 6. Okay? So whatever the answer we get, that will be the theta. So it's basically 5 pi by 6 minus 1 by 6 pi. You can just do it in your mind as well. It will be 4 pi by 6, or you can just write in calculator if you do, it'll calculate for you. So what is the outer radius now? Here it's 20 square minus. You can write the same thing again, but there is one trick. Instead of writing it many times, see here, half and theta is same. So you can take the half and theta outside. What remains is outer radius squared minus inner radius squared. So I'm just going to do that. These two will be the same thing. It's outer radius squared minus inner radius is unknown. So I'll take it as x squared. Since your calculator can solve this as equation, we will directly put it in the calculator, and it is electronic exam. You do not need to do any steps here. So we need to type it out. Half times, here you can write it as directly 4 pi by 6, but I'm just going to write whatever it is as it is over here, the substitution. It's 5 pi divided by 6 minus pi by 6. Or you can write 1 pi by 6, it's the same thing. Or you can write this answer 4 pi by 6 as well. Then this is all multiplied. Remember, when we have subtraction over here, put a bracket. Make sure you put the brackets properly. And here it's 20 squared minus x squared. I forgot to write the area first, but I'll write it now. Equals 314.16. So shift and solve, and then press equal to. The answer is 9.999. This is basically 10. So let's just see the answer. Here, this is all done. Yeah, it's 10 feet because 9.999 corresponds to almost 10. So over here, this radius was 10, the outer inner radius, and the outer radius is 20. Now don't get confused by, okay, it's so close, it might be 1 or 2. No, you need to do it in the area formula, and then only you'll get the proper answer. Now then we have to find the missing coordinates. Now this one over here, P1 times P2, that is the distance formula. It's similar to the distance formula. Let me write the formula. When the two coordinates over here, P1, P2 is equal to, see, this is r and theta, right? Coordinates of polar grid. What we need to do is the first one. Here you can write first one plus r2, second one squared. Now this will be minus 2 times r1, r2 cosine Theta, see now remember it's theta 2, the second angle minus the first angle. This is the formula. Now all we do is substitute here. What is P1 times P2? It's 4.174. That is equal to here. The first one is 1 and 1. P1 means R1 theta 1. Theta 1. R2 theta 2 for P2. So now we will substitute the values. It's here, it's 3 squared plus. Now we do not know what is R2. That is what we are solving. I'll just leave it as R minus 2 times 3 times R. Now we have cosine, all multiplied with cosine. It's 75 degrees minus 35 degrees. Now remember, when we have cosine, we directly can't put it in the calculator. If you just put this in the calculator, you will get an error. The reason being, when you take cosine to the other side, it should be cos inverse and all that. But still, your quadratics, never put it in calculator. What we do is we square it. We can put it in calculator, but after some steps. Square both the sides and then take all this to the other side, and over here, see how much you can simplify. Here we have to square it up. 4.174 squared will be equal to 17.42. So let me write it over here, 17.42. That will be equal to the square root, and square cancels off. So you're remaining with 9 plus r squared minus, what about this part here? You just put this in the calculator. 2 times 3 times cosine 75 minus 35. This is the answer. It's plus 4.59. But there's minus sign which remains. See, now this minus sign is already there. Whatever the answer we got over here is 4.59. I'll take it as 4.6. It's much easier. But this minus sign was already there in the equation. Okay. That's why if it was minus 4.59, then I would have to make it plus here. Now it's not over, there is r. Don't forget the r, which is a variable. So this is the simplification here. Now before I continue, I just want to tell you about the degree mode. Now see, these 35 and 75 are in degrees, and our calculator is also in degree mode. That's absolutely fine. But if at all yours was like this, see, shift 4. Now, if it was R over here, up here, that means it's radian mode. Your answer will be wrong. See, this is wrong answer. Either clear your calculator or press shift mode and 3. Now it's in degree mode, and now press equal to. This is the correct answer. Hope that's clear. Now, before we finish off, see, this is now looking as quadratic equation. You can see there's r squared minus 4.6r. Get this 17.42 to the other side will become minus 17.42 plus 9 will be minus 8.42. So now we just go to mode 5 and 3. This is quadratics. What is before x squared or r squared here? It's nothing. That's 1. Then we have minus 4.6. Lastly, we have minus 8. Now I have not pressed equal to here. Minus 4.6 equal to, then we have to press minus 8.42. The answer is 6. Okay, now see here, this is 6.00. You just take it as 6. The reason being, we have not taken all the decimal values, isn't it, over here? So that's why we'll just take it as 6. And then we have negative 1.4. Now here we are getting two values. Don't think, okay, radius can't be negative. It can be, it can be in the other direction. So we can consider both the answers. Just see which is the correct options. Both must be there. It's either 6 or 4.03. It's very close to 4. Here they have taken the exact values. That's the reason they are getting this answer. We are very, very close to 4.1. We got negative 1.403. That's also fine. So that'd be the answers. Now the remaining problem is the same thing, same formula, just the given values differ. Here they have not given you what exactly is missing. Theta. That's the theta 2 is missing. So you need to do the same formula, but just find theta 2. Similarly, the other ones as well. Here now everything is in radian. So please, when you're solving this cosine everything, make it into radian mode. Shift mode and 4. That'll be radian. And lastly here as well. So these are the answers. Here there are two possible answers, either 1 or 5.13. And that is the end of question 10. Please practice many problems and be very thorough with the formulas.